This is the solving the nonlinear section, meaning it's not a line, guys. It's raised to a second power, so they're quadratics. I'm going to show you the long way to do these two, and I'm going to show you the shortcut. And I would like you to use the shortcut from now on once we go through this. So look at the first two. First thing you're going to do when you have an inequality, identify the sign that you're looking at. What is the inequality sign? Is that less than or equal to or greater than or equal to? It says x squared is less than. Okay, so I want you to write that down. Write down less than or equal to. And what kind of a dot are you going to have at your, what we call critical points? What kind of dots are you going to have? Closed. How do you know they're closed? Because of the equals to, okay? Now, once you identify that, you just treat this like it's an equation. If I was going to solve this, I would move 5x over, and I'd move the negative 6, correct? So we got x squared becomes minus 5x plus 6, and we'll set equal to 0. So now we factor. You're going to have to factor on all of these. What are the factors of positive 6 that multiply to give me positive 6 but add to give me negative 5? What is it? Factors of 6, either 1 and 6 or 2 and 3. What's going to multiply to give me a 6 but add to give me negative 5? Yep. X, perfect. X minus 2, x minus 3. So when I solve this, I get x equals 2 and I get x equals 3. Now you guys are like, okay, well, great. What does that mean? So what you're going to do is on your number line, you're going to put your critical points. I call them critical points, key points, whatever. What you are looking at, guys, is 3 different sections. Do you see the section to the left of 2 where 0 is? Then there's a section in the middle. Then there's a section to the right. So what we're going to do is we're going to test points in each section and see where the inequality is true. So what is the easiest number to check that is to the left of 2? Easiest number to check would be 0. If you can use 0, I'd always use 0. So what I'm going to do is go back to my original inequality. X squared less than or equal to 5x minus 6. You guys don't have to do this formally. I'm just writing it out formally right now so you can see it. But you don't have to do it formally. So I have 0 squared less than or equal to 5 times 0 minus 6. What is 0 squared? 0, thank you. Less than or equal to 5 times 0 is 0 minus 6. So 0 is less than or equal to negative 6. Is that a true statement? Is that a true statement that 0 is less than or equal to negative 6?
No.
Is that true, yes or no? No, it's not. Okay, so I'm going to put a little x there. Now let's pick a number between 2 and 3. It's not going to be pretty. So let's pick a number between 2 and 3. Let's say 2.5. All right, so if I have 2.5 squared less than or equal to 5 times 2.5 minus 6. All right, 2.5 squared, for those of you that don't know, is 6.25. I'm just going to do it for you. 5 times 5 times 2.5, what's 25 times 5? Anybody? Yep, so it's 12.5, good. Minus 6. So this works out to be 6.25 is less than or equal to 6.5. Think about money. Is $6.25 less than $6.50? Yes or no? In your pocket, you have $6.25. Is it less than or equal to $6.50? Yes or no, guys? Come on.
Yes.
Yes. Okay, so this works. Let's pick a number to the right-hand side of 3, which would be what? Any number. Okay, 4. So I'm going to say 4 squared less than or equal to 5 times 4 minus 6. Well, 4 squared is 16. Less than or equal to 20 minus 6. Is 16 less than or equal to 14? No. So where is the only section that quote unquote works? Between what? between 2 and 3. What kind of dots at the beginning? What kind of dots did we say we're going to have at 2 and 3? Closed. So I'm going to close. And where this is the only place that works is right here in the middle. So that would be what my graph looks like. So interval notation, like we did yesterday. What would my interval notation be between for this graph? From where to where? Where did I color? What works? From 2 to 3. So it would be from positive 2 to 3 with brackets because it's a closed dot. All right. The only thing new here, guys, is you checking your points. And I'm going to show you a shortcut in a minute to where you don't have to do what I just did. Yes, ma'am.
Why did you pick like 25?
It's 2.5.
Oh, okay.
Yeah. No, it's okay. All right. Let's look at the next one. Tell me about the sign. What does that one say? 2x squared minus x is? Greater, right? Watch. Greater. I know I spelled it wrong. And then what kind of a dot am I going to have? Open. Why is it open? Because it's just greater than. All right, so now let's pretend this is just an equation. So 2x squared minus x. If I move the 1 over, it becomes minus 1 equals 0. So factor this. 2 times negative 1 is negative 2. What are the factors of negative 2 that multiply to give me negative 2, but add to give me negative 1? Okay, so negative 2, positive 1. And since a is not 1, I put it underneath. So I get x minus 1 and 2x plus 1. Agreed? So when I solve this, I get x equals 1 and x equals negative 1/2. When I move the 1 over, it becomes negative, then I divide by 2. You guys with me? Okay. If you're not, you got to tell me. So when I'm going to do my graph, because this is what my answer is, I have a point at negative 1/2, I got 0, and I got 2. What kind of dots do I have at negative 1/2 and at positive, oh, sorry, this should be 1. What kind of dots do I have at those 2 points? Tell me. Why are they both open? You're right. Okay. Thank you for being honest. Because it's open because there's no equal to sign underneath when you started. But good. Now, guys, let's pick. We got to pick numbers to the left, to the right, and in the middle. So what is the number that's to the left of negative 1/2? Okay, negative 1. So go back to your original. I'm going to say 2 times negative 1 squared minus negative 1. Is that greater than 1? Negative 1 squared is 1. 2 times 1 is 2. Minus the negative is a plus. So is 3 greater than 1? Yes. Okay, so over here, that side works. What's an easy number to pick in between negative 1 and negative 1/2 and 1? 0. We always like to do 0 if we can. So I have 2 times 0 squared minus 0 greater than 1. Right? Okay, so I have 0 minus 0 is greater than 1. Is 0 greater than 1? No. So the middle doesn't work. Now let's pick a number to the right of 1. 2, okay. 2 times 2 squared minus 2 greater than 1. 2 squared is 4. 4 times 2 is 8. 8 minus 2 is 6 greater than 1. So over here works. So on my graph, guys, if I was going to graph this, I can just zoom in. Where am I going to color? On the outsides, on the opposite. So I'm going to color this way. I'm going to color this way. So my interval notation, reading left to right, would be negative infinity to what stopping point? Where is my open dot? At what? On the left. You always read left to right. So negative infinity to negative 1/2. It does not include it, so it's a parenthesis. Then there's a gap. How do I say in math, oh, there's a gap? What's that letter that I put right here? The U, it's our union. So it's from negative infinity to negative 1/2. then it starts again at what? No, negative infinity to negative 1/2. Read left to right. Starts again at positive 1 and then goes to infinity. You're looking at the yellow graph. So this would be your answer right here. Now, interval notation. Yep. I want you guys to look at something. At the beginning of this problem, we identified that this was greater, and I wrote the word or. Do you see how in my graph it's either this piece on the left or this piece on the right? Do you see that? In the first example I did, we said it was less than. I want you to think of the word and when it says less than. Because in less than, where did I color? Did I color on the outsides or did I color between 2 and 3? Did I color between 2 and 3 or did I color this or that? Between. When you have a greater, your graph will always look like this, going in opposite directions. When you have a less than, it's always going to be between the two numbers. If you guys can remember that, your life is so much easier. You don't have to do everything I just did mathematically there. Let's look at some examples. I'm going to show you some. Let's do number 3. All right, first thing, we're going to do the shortcut. First thing we're going to do is identify the sign, what our graph is going to look like, and our dots. So if I look at number 3, it says x squared plus 5x plus 6 is, say it. Greater. If it's an or, that means that my graph should go in opposite directions. And then what should my dots be? Open. All right, now that you've done that, you've done a majority of your work. Just solve this like you would any equation. X squared plus 5x plus 6 equals 0. So if I factor this, what are the factors of positive 6? Guys at home, what are the factors at positive 6 that multiply to give me 6 but add to give me 5?
3 and 2.
3 and 2. Positive 3, positive 2. So I have x equals negative 3, and I have a point at x equals negative 2. So on my number line, I have 0, negative 2, and negative 3. Without even testing any points, let's just graph this. Look back at your notes from the beginning. And is it going to be in between or opposite directions? Look at your notes at the beginning. Is it going to be an in-between graph or are you going to color in opposite directions? So I'm going to put open dots at negative 3 and negative 2. And I'm going to color this way and I'm going to color that way. Now some of you are going to say, but I really want to check and just make sure. Okay, fine. Always use 0. Look at the graph that you graphed, right? If I plug 0 into my original inequality, should it make it true or not? Is it in part of my solution or is it not in part of my solution? It is, right? It's colored in. So when I plug 0 back in, it should quote unquote work. So let's do that. 0 squared plus 5 times 0 plus 6 greater than 0. This is 0, 0. So is 6 greater than 0? Yes, then you know you're right. You don't have to go through and check to the left, to the middle, to the right. Just always use 0, but look at your graph. If it's colored in, then it should work. If it's not colored in, it shouldn't work. So your interval notation, guys, remember we read left to right. So starting over here on negative infinity, where does the first part of the graph stop? Negative 3, perfect. And it should have a what in the middle, parenthesis, right? Because it doesn't include it. Then we have our union. And it goes from where? Where does it start again? Perfect. To what? Perfect. Very good.
Wait, so if it's greater than or equal to, are there brackets?
Yep. Question was if it's greater than or equal to, are there brackets? And the answer is yes.
In my homework, like, I had a hard time, like, putting in the interval notation. I don't know,
Okay. All right. Does it make a little more sense now? Okay. And again, it's practice. I know that. Duque.
What do you mean by, like, I understand the bracket thing, but when you use that something, like, I was thinking something
Okay, what you use brackets when there's an equal to sign underneath.
And you put it on the outside.
On the numbers, brackets only go on numbers, not on infinity. Is always a parenthesis.
And also, like, that's just the short way. So we like just so like we wouldn't have to like use like other numbers, and we just try to put 0 in.
If you can identify at the beginning which sign you have, that'll tell you what your graph should look like. And then I always just choose 0. And if it's colored in, then I know when I plug 0 in, it should work. And if it's in a section that's not colored in, I know when I plug in 0, it should not work. Let's look at the next one. Watch. Okay, tell yourself some stuff, guys, before we do anything. What does my sign say? X squared is what? Less than. So watch. I literally, I'll do this when I do your all's answer key. I write the word. I know that's not how you spell than. Less than. What does that mean? My graph should be where? Going opposite directions or in between two things? In between two things. And what in between those two things should my dots be open or closed? Open. If you need to, guys, put open and then put parentheses above it, because open means parenthesis. Closed is a bracket. So now we're going to just solve this like you would any other equation. When I move positive x over, it becomes negative x. When I move positive 2 over, it becomes negative 2. So let's factor. What are the factors of negative 2 that multiply to give me negative 2, but add to give me negative 1? Factors of negative 2. Add to give me negative 1. 1 and 2. Negative 2, positive 1. So I have my 2 points that I'm going to put on my graph are at positive 2 and negative 1. Does everybody agree? Okay. So I have negative 1, 0, and 2. Okay, remind me again, what are the dots going to look like at negative 1 and 2? Open, good. And since it's less than, where do you want me to color? Look at what you drew. In the middle. So let's check just to make sure. What did I tell you the easiest number to check is? 0. When I plug 0 into check, should it work according to my graph or should it not? Is it in the colored part or no? Yeah, so it should work. So I'm going to say 0 squared is less than or equal to 0 plus 2. Well, what's 0 squared? 0. Is that less than 2? Yeah, so you're good to go. So what's your interval notation? From where, reading left to right, it starts where and it ends where? Negative 1 to 2. And what do we have on either end? Parentheses. Good. That would be your answer. How do we feel? Good-ish. It's a little easier when you do the shortcut. Let's look at this one. There's a lot going on in this problem, but who cares? Let's do our little shortcut first. Identify the sign. It says 5x squared plus 3x is greater. Greater. What do I mean by or? What's my graph going to do? It's going to go in opposite directions. Good, Duque. And what is going to be, ladies and gents, what are my dots going to look like? Closed. Good. If you want to remind yourself what a closed dot means, put a little bracket. That means, I have to have brackets on my numbers. So now this just becomes a factoring problem. This is 5x squared plus 3x equals 3x squared plus 2. I want to get everything on one side. So I'm going to subtract 3x squared from both sides. I'm going to subtract 2. So I have 2x squared plus 3x minus 2 equals 0. You guys with me? Okay, so now we're just factoring. Factoring never goes away. What are the factors? I have to do a times c. What are the factors of negative 4 that multiply to give me negative 4, but add to give me 3? 1 and 4. Good. So x plus 4, x minus 1, because I want a positive 3 when I add. But my a term, ladies and gents, my a term is not 1. My a term is not 1, so I'm going to divide both of these by 2, right? So this becomes x plus 2 and x minus 1 over 2, or 2x minus 1.
Like, did your 18 always have to be 1? Like,
If it's not 1, you have to divide by it.
okay.
So now when I solve this, I'm going to have 2 points. One at x equals negative 2 and one at x equals positive 1/2. When I move the negative 1 over, it becomes positive. And then I divide by 2. You guys with me? Okay, so let's do our graph. I have points at negative 2, 0, and 1/2. Go back to the beginning. Without even testing points, what did you guys tell me my graph was going to look like? Opposite directions. What is the notation on the end of each of the graph pieces? It's a closed dot. Okay, so I know that it's going to be closed dot here, closed dot here. So my interval notation, if there is a gap, which is right here, there's a gap, you should have a U when you do your interval notation. So it's going to be from negative infinity to what number? Negative 2. Bracket, because it's a closed dot. Then I have my union. Where does it start again? Positive 1/2, so I have my bracket, comma, infinity. Now we can check to see if this is right. What is the easiest number to check with? No, it's okay. You can still check with 0. When I check with 0, should it work or not work? It should not work. So let's go back to the beginning. Where's my original? 5 times 0 squared plus 3 times 0. Is that greater than or equal to 3 times 0 squared plus 2? Well, what's 0 squared? Times 5. 0. Plus 3 times 0. 0. So I have 0 greater than or equal to 0 squared is times 3 is 0 greater than or equal to 2? No, it's not. Is that part shaded in my graph? No, it's not. So are you correct? Yes, you are. All right, this takes a little extra time. I understand that. But it's absolutely nothing you guys can't handle. If you can remember the shortcut, your life is much easier, I promise. I promise. All right, I have a couple more. Okay, guys, let's look at number 6. First thing we want to do is identify our sign. So this is greater. That means my graph is going to go in opposite directions. And since I do not have an equal to sign underneath, it's going to be an open dot. And remember, when we have open, we use parentheses at the end of our graph. So, just the normal equation, x squared plus 2x, x squared 2x minus 3, because when I move the 3 over, it becomes negative, equals 0. So I need factors of negative 3 that multiply to give me negative 3, add to give me 1, be plus 3 minus 1. So I have points at x equals negative 3 and x equals 1. So when I do my graph, I have negative 3, 0, and 1. And we talked at the beginning, I should have open dots at my negative 3 and 1, and I'm going to go in opposite directions. Remember, where the gap is your union. So we start over here at negative infinity. I'm at negative infinity to negative 3, parenthesis, union, 1 to infinity, in all parentheses because there's no greater than or equal to. So now to check, just to make sure we're okay, I'm going to plug in 0. 0 should not work. It's not in the area of the shaded region. So when I say 0 squared plus 2 times 0 greater than 3, 0 squared is 0 plus 0, so I have 0 greater than 3. Does that work? No, it does not. So we're good to go. Here's our answer. Okay, the next slide. All right, these 2 more examples and then we're good to go. Again, let's check out what our signs are and what our graph should look like and all that stuff. So I have x squared is greater than or equal to 9, so it's greater. That means my graph is going to go in opposite directions, and since it's or equal to, I know I'm going to have closed dots And I know with a closed dot, I use bracket notation on the numbers. Negative infinity to positive infinity always has parentheses. But I have on the numbers a bracket. So I'm going to say x squared. If I move the 9 over, it becomes minus 9 equals 0. When we factor that, that's just the difference of perfect squares. So x plus 3, x minus 3. So I have points at x equals negative 3 and x equals positive 3. So I have negative 3, 0, and 3. We said at the beginning we have closed dots. And it's greater, so it goes in opposite directions. It's either this or that. And I have my union right here. So let's check 0. 0 should not work. It's not in my shaded in region. So I have 0 squared greater than or equal to 9. Well, 0 is not greater than or equal to 9, so we're good to go. So when I write my interval notation from negative infinity to positive infinity, it's negative infinity to negative 3, bracket, union, 3 to infinity. And there we go. Okay, and number 8, this one's already factored for us. So we can just write this as x plus 3, x plus 3, x plus 1 greater than 0. So it's greater. That means my graph is going to go in opposite directions, and it's not, or equal to, it's just greater, so it's an open, and we're going to have parentheses. So when I solve this, I get a point at x equals negative 3, and I get a point at x equals negative 1. So on my graph, I have 0, negative 1, negative 3. We said that it's in opposite directions, and I have open dots, so open at negative 3 and negative 1, and I'm going to color in opposite directions. So I'm going to plug in 0. 0 should work. So when I plug in 0, I have 0 plus 3 squared times 0 plus 1 is greater than 0. Well, 0 plus 3 is 3, and 3 squared is 9, times 0 plus 1 is 1. Is 9 greater than 0? Yes, so we're good to go. So our interval notation, remember, negative infinity is over here, positive infinity is here. We read from left to right, and this is the gap. Where's my union? So I have negative infinity to negative 3 and a parenthesis because my dot is open. Union, negative 1 to infinity. And there's our answer. So tomorrow, guys, we will work on solving the ones below this where they're quotients. It's a little more involved, but nothing you guys can't handle. You'll be fine. All right, see you tomorrow.